Hello students, I am Dr. Nimi Singh. Today I am going to present you a module in BSc Forensic Science on behalf of the content writers Dr. GSOD and Ms. Tulika Banerjee on an important unit of forensic ballistics, which is Firearm Evidence, the part 7, in which we are going to discuss about the determination of range of firing, the use of X-ray photography, range of firing estimation for rifle, firearms and shotguns, various chemical tests used for range of firing estimation have also been discussed. We will wind up this module with a case study. Let us start our lecture with a look at what we are going to learn today. The first thing we are going to learn is the range of firing estimations, use of X-ray photography, range of firing estimation for rifle, firearm, chemical test for range of firing estimation, range of fire estimations for shotguns, and later on we are going to conclude it. Range of fire can be determined using proper sketches, description of injuries, suspected firearm and the ammunition similar to the one used in the commission of crime. Fairly accurate estimate of the range can be made if skin surrounding the wound in close range shots is sent for GSR analysis. There are various factors through which the range of the fire can be determined. The first one is the muzzle pattern. When a firearm pressed against the target is discharged, the muzzle leaves its imprint on the target. The muzzle pattern therefore indicates a contact wound. The contact wounds are usually observed in suicide cases, but they are also seen in some murder cases. The muzzle pattern also appears on a corpse if a firearm is pressed against the corpse and then fired. Then comes scorching. The scorching of the target is caused by the flame or by very hot gases. It is a sure sign that a firearm has been fired from a close range. The hot gas can travel forward only to a limited distance, which varies from a few centimeters in case of pistols and revolvers to a decimeter in case of shoulder firearms. It depends on the length of the barrel of firearm and the quantity and age of the propellant and other constituents of the cartridge. The proper initiation and the burning rate of propellant in the firearm also affect. Scorching, burning, singeing or charring is taken as synonyms. They are often confused with blackening, dirting and contusion rings. They can be distinguished easily. The blackening and the dirting can be removed by swabbing the surface with spirit. This process removes the dirt, but charring remains. Then comes blackening. The blackening around the wound is caused by the deposition of smoke by all types of propellants when the shots are fired from a very close range. The intensity of the color is maximum with gunpowder, less in semi-smokeless powder and least in smokeless powder when fired from the same range and with equivalent quantities of powders used in the ammunition. The color of smoke deposited is more or less grey to black depending upon the quantity of the smoke deposited and the nature of powder used. Then comes the tattooing. It is also called as peppering or stippling. It is nothing but the embedding of the unburnt or semi-burnt powder particles into the target surface. These particles are slightly heavier than the smoke particles, so they retain motion for a somewhat longer time than the smoke particles. So, consequently, the tattooing has a longer range, about 1.5 times than that of the blackening range. The age and quality of powder charge and the length of the barrel have a predominant influence on the range and intensity of tattooing. Then comes the metallic residues. The GSR may contain iron, tin, lead, barium, copper, etc. Iron comes from the barrel. The metallic residues may be propelled up to 2 to 3 meters or more. The elemental metal particles may sometimes be found at the target. They are then scrapped from the projectiles by the barrels. They form part of the projected charge. They, being heavier, travel to a longer distance than the powder and smoke particles. Now, the range varies with the firearm, the ammunition, and mainly with the size of the particles formed. Then comes the Wad distribution. A number of wads are found in a shotgun cartridge. They are projected along the other charge. They enter the target up to about 2 to 3 meters. If they are not obstructed, they scatter from 5 meters to a long distance. If the distance between the victim and the wads is known, then the range of fire can be determined. The majority of wads scatter over a range of 3 to 50 meters. The overshot wad was found the nearest, while the cushion wad goes to the farthest point. Then comes the pellet pattern. The area covered by the pellets fired from a shotgun is a function of the distance between the muzzle of the firearm and the target. Longer the range, larger is the area covered by the pellets. The spread of pellets is mainly affected by the length of the barrel of the firearm and its muzzle characteristics. Now comes the unburnt and partially burnt propellant particles. The propellant particles can travel longer distances and can be found at targets in case of long range fire as they are much heavier. They can be located at the target with the help of low power microscopy. For example, they can be located at a distance of 30 meters for a handgun and to over 40 meters for a rifle. For determination of sequence of events in a shooting case, presence or absence of such particles may play an important role. The factors affecting these particles are similar to those affecting the discharged particles as discussed above. These propellant particles have a tendency to strongly adhere to the fabrics. These particles will melt the fabric and bond with it. In case of close range fires, these enter into the epidermal layer of human skin and form tattooing which cannot be removed. For analysis of gunshot wounds, X-ray proves to be very useful for forensic investigators. It helps in determination of bullet inside the body, locating exact position of the bullet in the body, locating and determining the caliber and the type of bullet in case the bullet cannot be removed through surgery, determining the path of the bullet, determining the location and position of wads and pellets in case of shotgun wounds before surgery. In various cases, using X-rays actually saves time as position of the bullet in the body can easily be determined without any time consuming dissections. Now, range of fire can be accurately determined by analyzing the impact of discharged residues from a close range fire, that is up to 2 feet for handguns and 6 feet for rifle. In case of close contact of the muzzle with the skin, discharge residues may be completely absent. Due to the absence of discharge residues, sometimes the entry hole is mistaken for exit hole. In such cases now, the residue enters inside the wound along with the bullet and does not leave any trace around the margins of the wound. The gases then get trapped in those areas where skin and subcutaneous tissues covers the bone. The expansion of gases is extremely rapid and they try to exit from the same hole from which it entered. Since the amount of gas is large in volume, the only way is to exit through the entry hole. This leads to gaping stellate, tear with blood, tissue and portion of bone coming out. A proper examination of such type of wound is necessary to give accurate opinion and for not mistaking the entry wound as exit wound. Partially burnt or unburnt particles should be analyzed for correct identification of the wound and for accurate determination of range of fire. The impact of discharge residues can be easily determined at greater ranges as compared to the tight contact fires. Usually, simple visual examination under a low power microscope is done for detection of these components. Comparison with test fire samples can also be made, but it should be stressed that the test fires are from the same firearm and ammunition for a correct comparison. Discharge patterns can be variable in case of different ammunition and firearm. The amount of discharge residues reduces if the length of the barrel is longer. The target material selected for conducting test firing for estimation of range of fire is also very important. For example, the test patterns obtained on a smooth man-made fiber would be different from those obtained on thick woolly material, thus making it difficult for comparison and of less importance, whereas a range of fire estimation of skin when compared with test fire on pig skin would provide more meaningful results. The amount of discharge residue present will depend on various factors such as range, weapon type, propellant type, barrel length and the type of ammunition used. The effects are mainly split into three categories: scorching, blackening and unburnt and partially burnt propellant particles, as we have already discussed above. Scanning electron microscope, we usually call it as SEM, is commonly used for determination of range of fire, but in cases where SEM cannot be used or is not available, then chemical test can be used. Since no test is specific for a particular substance, the interpretation of the results should be done very carefully. Let us now discuss some of the tests. Walker test for nitrites. This test is employed for the presence of nitrites in the partially burnt and unburnt propellant particles. In this test, a photographic paper is desensitized in hypofixer. After that, the paper is immersed in a solution of 5% 2-naphthylamine 4,8-disulfonic acid. Then it is air dried. A cloth wetted with 20% acetic acid is placed under the clothing under test. The photographic paper is then placed on top and covered with a piece of dry cloth. Pressure is applied with a hot iron set at warm for 5 minutes. Appearance of bright red spots indicates the presence of nitrite. It should further be noted that many compounds other than nitrocellulose propellants can give a positive reaction. For example, urine, face powder, fertilizers. Now coming to the second test, which is the Greiss test. This test is same as the Walker test, except that the main reagent is naphthylamine instead of 2-naphthylamine 4,8-disulfonic acid. This reagent results in orange spots. Greiss test is chiefly employed for the detection of propellant particles in estimation of range of fire. Then comes the Marshall test. The desynthesized photographic paper is soaked in a 0.5% solution of sulfonylate acid for 10 minutes and then dried. This is then soaked in a 0.5% solution of N,A-naphthethylene diamine E hydrochloride in methanol for 2 minutes and then again dried. A cloth wetted with 20% acetic acid is placed under the clothing under test. The photographic paper is then placed on top and covered with a piece of dry cloth. Pressure is then again applied with a hot iron set at warm for 5 minutes. A positive indication for nitrites will appear as purple spots on a purple background. It is then rinsed in warm water to remove the background color and then rinsed in methanol. The spots will then turn orange. This test is mainly used for the detection of propellant particles in range of firing estimations. Coming to Tewari test, 1 gram of entazoline hydrochloride is dissolved in 50 ml of water. 45 ml of concentrated HCl is added and stirred until the white precipitate dissolves. A filter paper is then soaked in acetone and pressed on the target. It is then air dried and sprayed heavily with the prepared entazoline solution. Nitrite compounds will register a positive reaction as deep yellow spots. This test is mainly used for range of firing estimations by visualization of propellant particles. Now coming to the Harrison and Gilroy reagent. This reagent is actually intended for the identification of GSR on hand swabs, but also be used just as well for range of firing estimations once the particles have been removed from the garment. The photographic paper method of lifting the residues from the clothing is used, but dilute HCl must be used instead of acetic acid. It is then air dried and sprayed with a 10% solution of triphenyl methyl arsenium iodide in alcohol. An orange coloration appears showing positive reaction for the presence of antimony. It is then dried and sprayed with a saturated solution of sodium rhodizonate. Red spots appear showing positive reaction for the presence of barium or lead. When dried and sprayed with dilute HCl, purple spots will appear indicating positive reaction for the presence of lead. If the spots are then exposed to a 35% ammonia solution, any particles containing barium will now give a red coloration. Since shotguns fire pellets loaded in cartridges instead of single bullet, it is possible to determine the range of fire up to a distance of 20 to 30 yards. Estimation of range of fire is done on a fact that pellets do not travel in a single unified mass, but it begins to disperse after leaving the muzzle of the firearm. The air pressure between the pellet mass leads to the dispersion of these pellets. These continues till the pellets hit the target. The degree of dispersion of pellets depends on various factors such as cartridge pressure, Wad type, barrel choke and barrel length. Cartridge pressure. Now, the dispersion of pellets is more if the pressure generator is more by the cartridge, but the use of wads balances this effect and does not affect the dispersion of the shot. Coming to Wad type. Now, various types of wads are used in shotgun cartridges over, such as cushion wad, over powder wad, under powder wad, etc. The main function of over-powder wad is to seal the gas produced to prevent high-pressure gases to escape into the column. The cushion or filler wads are used as a pad to the shot against rapid acceleration, whereas overshot wads keep the shots in the cartridge case. These wads are then projected along with the other charge. They enter the target up to 2 to 3 meters. If they are not obstructed, they scatter from 5 meters to a long distance. If the distance between the victim and the wads is known, the range of fire can be determined. The majority of wads scatter over a range of 3 to 50 meters. The overshot wad was found the nearest, while the cushion wad goes to the farthest point. Then comes the barrel choke. When the diameter of a barrel of a shotgun is same throughout the barrel bore, it is called a true cylinder. The bore of the shotgun is sometimes reduced near the muzzle end, that is, the diameter near the muzzle and is slightly smaller than the diameter of the bore of the rest of the barrel. The barrel is then said to be choked. The choke may be half, full, quarter or improvised cylinder if the diameter at the muzzle end is reduced by 1/2, 1/4 and about 1/10 of a millimeter respectively. The choke increases the effective range of a shotgun by increasing the concentration of pellets per unit area at the target. For example, for every 100 pellets fired, 70 pellets will fall in a circle of 75 centimeters at a range of 30 meters in a fully choked barrel. The number of pellets falling in an equal surface, repeat, the number of pellets falling in an equal circle under similar conditions for a true cylindrical barrel is 40 only. So, the tighter is the degree of restriction, tighter the pattern of shot at the target. Then comes the barrel length. Cutting the barrel from muzzle end and shortening it would have some effect on the spread of shots. The propellant used in shotguns are fast burning, which leads to the production of large amount of pressure during the first few moments of burning. In case of full length barrel, the pressure drops considerably as the barrels reach the muzzle end and there is increase in the volume of gas between the over powder wad and the standing breech of the firearm. Since the length of the barrel is decreased, the pressure exerted on the base of the shot column increases. This leads to a destabilized shot column and a blown pattern. Range of fire can be determined using proper sketches, description of injuries, suspected firearm and the ammunition similar to the one used in the commission of crime. The various factors by which range can be determined include pellet pattern, muzzle pattern, scorching, burning, presence of unburnt and partially burned residues, etc. Moreover, X-rays can also be used to study the gunshot injuries.